as usual, let's stop something. As usual, the task there when it comes to resolving, of course, for this, the degree of numerator, hold on, the degree of numerator and denominator are the same thing. Yes or no? Check. The degree of numerator here and denominator are the same. Yes or no? Huh? Yes, let's turn up. Yes, let's turn up. Yes. No people now. Yes, let's turn up. No, let's turn up. You don't know, let's turn up. For this one here, degree of C. If I have, for example, if I have this x plus 2 all squared, this is equal to x plus 2 multiplying x plus 2, which on expansion I'll have x squared plus 4x plus 4. You can always know the degree. Listen, you can always know the degree of any term by multiplying the highest power, by multiplying the degree of, by multiplying the highest degree of the variable by the degree outside. So in this case here, degree here is 1, degree here is 2. 1 times 2, 2 is a degree 2 question. In other words, if this one will be, let's say, x cubed plus 2 all squared, this will be equal to x cubed plus 2 multiplying x cubed plus 2. And that will give you x power 6 plus 4x power 3 plus 4. Again, you always tell the degree by multiplying the highest degree here by this one. 2, 3 times 2, 6. So in this case here, with that same concept, 1 times 3 is 3. So on expansion, this one here is a function of degree 3. Here is a function of degree 1. So hence, this one is lesser than this one. So resolve this one here into partial fraction. When it comes to resolving this stuff, if you can remember partial fraction, this is under which of the functions? Repeated roots, Abi? Yes. For repeated roots, remember how you write it? Yes. In acidic power, Abi? Yes. Alright, so this will be what there. If I pick this one here and resolve the partial fraction, what will be my form? For this one, it becomes 2x plus 1 all over 2x plus 3 all over there, cube. What will be the form there? A all over 2x plus 3 Abi? Plus b all over 2x plus 3 plus all over all what that. So that's your form. So your key to solving partial fraction always lies in, can you remember the correct form? That's it. Partial fraction is on my channel. Go to playlist, look for mathematics, check the last video, you see partial fraction. I've shared the link on the WhatsApp group. You see partial fraction, go and revise them. Alright, what's the tax here? How do you solve this partial fraction? What do you do? 2x plus 1 all over 2x plus 3 cubed is equal to what the LCM here? This one. My LCM here is 2x plus 3 cubed. Alright, so look at this please. This now, 2x plus 3 cubed dividing 2x plus 3. This will cancel remaining what there, this one there, square. Abi? So it gives you what there? A into 2x plus 3 what there? Square. Plus, divide this by this here, to power 3 to power 2. So if I divide them, we subtract the part. 3 minus 2 is 1. So only one of these is left. It becomes b multiply this to power 1, 2x plus 3 to power 1. This is same as this. Plus, finally, divide this one here by this. That is same thing, you cancel out. Leaving what there? 1. Becomes c times what there? 1. So I have this. Again, we provide the link to this, the link to partial fraction is on the description of this video. Just check it out. Alright, let's get this done. How do you solve this stuff? How do you solve this stuff? This becomes, okay, which method do we use here to make it easy? Which method? At this point, hold on, at this point I say equating numerators, you have 2x plus 1 is equal to a into 2x plus 3 squared plus b into 2x plus 3 plus c times 1 is c. So how do you solve this? What do you do? Huh? Cover up. Cover up. Expand. Cover up would work. Cover up would work, but we can get only just, I think I get just C. For cover up, we get just C. We know for B and A. So, better we expand this. Expands I have 2x plus 1 is equal to A. If I expand this, gives what there? 4x squared plus 12x plus 9. Expand this to get this. Plus b into 2x plus 3 plus c. Then we can expand this, right? All right. Expand is what do I get here? 2x plus 1 is equal to this 4ax squared plus this and this 12ax plus this and this 9a plus this and this 2bx plus this and this 3b plus c. At this point now, collect like terms. Okay? Collect like terms. So I have that 2x plus 1 is equal to 4ax squared. X times 2ax, 2bx. So this is 12ax plus 2bx. That's our take constant plus 9a plus 3b plus c. So I have this. Factorizing, I have 2x plus 1 equal to 4ax squared. For the x, I have 12a and 2b. So it gives you plus 12a plus 2b all into x. For the constant I have plus 9a plus 3b plus c. So I have this. Of course, comparing coefficients. Comparing coefficients. For x squared, there is no x squared here. So 0 is equal to, coefficient of x squared here is what? 4a. Equation 1. Next up, for x, coefficient here is 2. So 2 is equal to, here is this, 12a plus 2b. Call this equation 2. For constants, I have here 1 is equal to this one here, 9a plus 3b plus c. Call this 3. Alright, from 1 to 3, start solving them one by one. Obviously from here, the first one I can solve is for a here. So from equation 1, you have that perhaps 4a is equal to 0. So get a here becomes 4a over 4. So you have that 4a over 4 is equal to 0 over 4. This cancels this. A is equal to 0 over 4. What do you get there? You have 0 there. Got to A at 0. Let's get B and C. Alright, let's start. Put A into 2. So put A into equation 2. I have that 2 is equal to 12 times, so A0 is equal to 2B, this one, sorry, plus 2B. Right, 2 is equal to 12A plus 2B. So this is 0. So I'm left with 2 is equal to 2B divided by 2 divided by 2. This cancels this. So hence B is equal to what there? 1. A is 0, B is 1. Let's get C. So put A and B into 3. Put A and B into 3. Into 3, what do I get there? 1 is equal to 9 times A, 9 times 0, plus 3 times B, 3 times 1, plus C. Perhaps. So 1 is equal to 9 times 0, 0, 3 times 1, 3, plus C. Alright, so I have C will be equal to, so it comes here, 1 minus 3. How many there? Minus 2. So hence, A is 0, B is 1, C is minus 2. So therefore, help me recall that partial fraction game. Therefore, what was the stop there? Sorry, therefore 2 1. All over 2x plus 3 all cubed. This one is equal to, we said A all over what there? 2x plus 3 plus B all over 2x plus 3 all squared plus C all over 2x plus 3 all cubed. If I replace what each of the actors represents, A we said is 0, B we said is 1, C we said is minus 2. So this is what happens here. C is minus 2. This minus comes down here. I'll now have this as minus the 2 is not up. So we'll do this. Right? Plus minus 2. Take this minus down here. Plus minus minus. So I have this. So you see what there? 0, I mean? Yes. When 0 is at numerator, it gives you 0, so it's off. So hence I'm left with 2x plus 1 all over 2x plus 3 all cubed is equal to 1 all over 2x plus 3 squared minus 2 all over 2x plus 3 cubed. At this point, I have not started solving. I only resolved into partial fraction. So now, let's now integrate. So integrate this question with respect to the x. Integrate this with respect to the x. Integrate this with the x. So I have this. Alright, so now I have this. Question. How do you integrate this thing? Which method do you use? Substitution. So using substitution method. Now remember I told you, this will not be lean. Why is it not lean? I said only use lean when here is what there? Linear. So assuming this score was not there, it would have been lean 2x plus 3. Because here is linear. But for this one, the here is not linear. The part here is square. This is quadratic. But then you expand this what there? Cubic. So I'll substitute this one here. See, these are now two questions. I'll solve them side by side using substitution. See why I solve this. See why I solve this. This will be equal to, see why I solve this, the integral of 1 all over 2x plus 3 all squared dx plus integral of 1 all over minus integral of 1 over 2x plus 3 all cubed dx. Okay, 2 over times. Alright. Minus the integral of 2 all over 2x plus 3 cubed. Yes. How do you solve this? Using substitution. Now see the idea. At this point, you divide this question into two halves and solve them simultaneously. So I'll have this one like this. So I'm having this half and this half. From this one, we say, for this we say, let u be equal to what I have there, 2x plus 3. If I differentiate, I have that du all over the x is equal to what there? 2. Constant is 0 is off. Let's get the x here. The x is equal to, I say swap this 2. Becomes what there? Du over what there? 2 for this part. Come to this part, so we say let u be equal to 2x plus 3. Same tax here. Du over dx is equal to 2. From here we have that the x, swap this 2, is equal to du over 2. And you ask it, these are the same thing. So why do I have to differentiate them? The idea is this, to give you the pattern. In this question, somehow, these two are the same thing. In some questions, these two will not be the same thing. So that we have to do that differently. But let's solve this one here. So substituting for this one, substituting, what do I have? This becomes the integral of 1 all over, this is u, so u what there, squared, dot, what's the x? The x is what? Du over 2, for this one here. Something for this one here, I have minus integral of 2 all over, we call this u, so it becomes what there? U cube dot dx. What's dx here? Du over what there? 2. Observe these cancels out there. 1 for this case. Alright. So let's put these two side by side as we've done. Alright. So for this, this is now equal to, what do I have here? My task will be this. Take constant outside integral sign. Express this one here as express this one here in index form. Take constant. The constant here is 1 over 2. Take it outside, becomes 1 over 2 integral of 1 over u squared dot du. For here I have minus, becomes minus integral of 1 over u cubed du. This one they are. Express this one here in index form, 1 over 2 integral of u to the power 1 there, minus 2 du, minus integral of u to the power 1 there, minus 3 du. Alright, so at this point, this becomes 1 all over 2. If I integrate this, it becomes u. Add 1 here, becomes minus 2 plus 1. All over minus 2 plus 1. Yeah? This becomes minus, integrate this becomes u into add 1 here, minus 3 plus 1. All over minus 3 plus 1, of course, plus c. The constant of integration. So we're integrating this one here using the idea of general method of integration. From this, I'm having this as 1 over 2 into, this gives u to the power minus 2 plus 1 is minus 1 all over minus 2 plus 1 is minus 1 into minus, this gives u into minus 3 plus 1 minus 2 all over minus 2, of course, plus c. So we have this. We'll try to simplify this as much as we can. So if I simplify this, I'll get this as being, this becomes 1 all over 2. And I'm having this as, this is, this one here gives you dot 1 all over minus 1 dot u to the power minus 1. If I separate this one here, this is 1 over minus 1. Separate it. Then u to the power minus 1. Same case here. Minus. Separate 1 over minus 2. So into 1 all over minus 2 into u to the power minus 2 plus c. So I'm just separating these ones from u. So this gives you 1 all over minus 2 u to the power minus 2 plus c. If I work this out, this will give you 1 over 2. This one here gives minus 1. Multiplying, this one gives 1 all over u. Minus, this gives minus 1 over 2. Into, this one gives 1 all over u squared, then plus c. If I work this out, this now gives you 1 times minus 1 times 1 gives you minus 1 all over 2 times u gives 2u minus, so minus minus gives you plus 1 times 1 is 1 all over 2 times u squared is 2u squared plus c. So I now have this as being equal to 1 all over 2u plus 1 all over 2u squared plus c. But u is equal to 2x plus 3. 2x plus 3. Hence, I have that my final answer is 1 all over 2 into u, 2x plus 3, plus 1 all over 2u, 2x plus 3 squared, then plus c. So this now becomes the result or the answer to that question. So this is how you answer that particular question.